Thank you, ma'am. General Arora, sir. General Srivastava. I should make a special mention that I don't know whether I can say that I'm going to miss him after this, but it's been a very inspiring tenure along with you. And Admiral Sandeep Nethani, a very inspirational figure. He was giving us a talk in the PhD chambers just the other day on how we are integrating the micro, small, medium enterprises into the entire ecosystem, and that's where I think we have to focus a little more. General Verma, a very good friend, and also a technologist and a soldier. I don't know, he's putting in the efforts on which side of either the scholarly side or the soldierly side, but yes, he's there. Ladies and gentlemen, veterans, officers, it's so nice to be here talking about military power systems. And I don't need to restate whatever has been stated till now. We all know that military operations are heavily dependent upon equipment and systems. And therefore, while the man behind the machine is very, very important, and we cannot. And one of the greatest lessons that we have ever learned in the Israel's war against terrorism, if there is one lesson, and that lesson is boots on the ground, and therefore not talking about the boots on the ground, which was absent in the south, and therefore all this had to happen. Otherwise, even a small quick reaction team could have probably been enough to thwart whatever had happened at that time. So we are talking about systems that are enduring harsh temperatures, exposed to various fragilities of war, and we are talking about powering systems which are going to be working in contested environments. And when we talk about a contested environment, then I think we need to focus on how the TBA will look like at any point in time, and therefore, I mean, my memory goes back to about some 30, 40 years, and I remember the huge generators making a lot of noise, and also sending in those disturbing waves to the systems that are placed adjacent to them. And therefore, one of the things that always comes to my mind is the purity of power. When we talk of power, what is more important is the purity of power. So, for example, if you were to pick up Lutyens Delhi, and I mean, my little stay in Lutyens Delhi, I was told that we don't require stabilizers, or we don't require UPS and things like that, because the power which is delivered to Lutyens Delhi is pure. I do not know if it is the privilege of only the rich and famous, but if at all there is a privilege to purity of power, I think it should be to the warfighters. And I think that's very important. And when we talk of purity, and that's where you talk about excellence, and I just want to quote from the Bhagavad Gita what Lord Krishna says about excellence. Manushyanam sahasreshu kaschit yatati siddhaye siddhanam api yatatam kaschit mameti tatvatah, purity. Who will achieve purity? Manushyanam sahasreshu. There will be so many people who are doing power systems, so many companies are doing power systems, so many people are supplying to the armed forces, so many. But how many of them are kaschit yatati siddhaye? How many are coming to siddha, perfection, in terms of power? And amongst those, who are those who are reaching what is called the pinnacle of purity? And I think that's very important. So without wasting much time on philosophy, I would like to now go and dwell into how we have structured the paper, the knowledge paper that's going to be released in a few minutes from now, written by an expert, Tejasvi Singh, who's sitting there. We have started about talking about the powering of military platforms, land, air, maritime, and also the unmanned aerial systems. we had talked about the logistics in powering the system. So you see, whenever you talk about a generator, whenever you talk about the power systems, there's so much of logistics involved. You carry all of them to the battlefield. You start charging on the battlefield. You start, you create so much of nuisance actually for the warfighter. So how can this nuisance be reduced? Is the question that we need to address. General Srivastava talked about the distributed power on the soldier, and that is something I feel very concerned about many times, because I was one of those guys who've been carrying a radio set on my back, and it keeps hitting your lower back because the battery is so heavy, and then it runs out very quickly, and therefore battery charging becomes important. I remember a very difficult situation when we were doing some flood relief on the Brahmaputra in Assam. So what really happened was, in about a couple of days' time, our battery charging and the management of power was found to be the weakest link in the entire operation, and therefore I think we need to concentrate on that. Then we have talked about the soldiers as power centers, and therefore today a soldier carries a lot of equipment on himself. It could be a radio, it could be a night vision device, it could be a smart helmet, it could be a smart tablet, it could be so many things, and therefore we need to see as to how we are going to achieve that type of a perfection over there. We have also talked about the global developments. China has come out with what is called as a Stirling engine. And those of you who know about the Stirling engine, our farmers in Punjab have been using this for some time. And this is a very interesting engine which gives you power which is so quick and so efficient, and also over long periods of time. And I think we need to see how we can master that type of a technology, while China has introduced it actually into space. Sikorsky has been building a long-range hybrid electric vehicle vertical takeoff and landing demonstrator. The technology demonstration has been given, and this is for the future military operations that they have demonstrated this. And therefore, I think we need to take a cue from here and see as to how are we preparing ourselves for the future. United States-based Delta Hawk engines had developed what is called as the aircraft piston engine, which is working on hydrogen fuel. Of course, we have also tested I think our Sukhois on a hybrid fuel, but I think these are cosmetic steps. We need to go further deep down into it. We have also talked about the India's power system sector. The investment in transmission and distributing infrastructure. We talked about the liberalization of the power market, the development of smart grids, digitalization of the power sector. And one of the important things was the cross-industry demand, which is fueling indigenization. So one of the prime examples is the growth of the telecom industry. And that led to a lot of investments in renewable energy, and approximately 315,000 base trans receiver stations have been set up, and about 100,000 new telecom sites have come up, and some 300,000 sites are being upgraded to accommodate 5G. And while we are preparing for the 5G and beyond 5G, when we talk of 6G, and we want to sort of get into a battlefield scenario where we are going to talk about a very, very seamlessly integrated battlefield. And today when we see one of the commands in the US has already sort of tested that, and sites like Nevada have gone into advanced testing of some of these power systems integrated into what is called as the future of the communication technologies, and where we talk about an integrated battlefield. And then we talked about diversification of generation sources. We talked about the integration of renewable energy, how that can get integrated into the larger grid. Then when we came to the power systems for military, we have seen, it's been witnessing a growth, all right. But what has happened is the strategic moves, this underscores the nation's commitment to sustainable energy, which was talked about. We showcased some of these in innovative battery solutions. We also have, for the development of new technologies, some challenges have been thrown under the IDEX. Now, is that good enough? Are we actually exploiting the IDEX to an extent that see what ultimately happens in IDEX? Whatever I've seen a little bit is once the company comes and it demonstrates and everything is successful, a small order is given. I think they are looking for those big orders. We have to look as to how we can scale them up. We cannot leave them at the stage of a small orders, which is for testing and this thing. We have to actually scale up. Maybe we are still at nascent stages. As we go forward, it's going to be there. We have seen the miniaturization of electronic modules, development of inertial energy storage systems for naval applications, actual flux motor based on lightweight electric OBM. The Admiral talked about it, the micro propulsion systems for the CubeSats, and propulsion systems for autonomous and road vehicles. All these are there. We've also touched a little bit about the foreign dependence, and this was also discussed by speakers before me. We are in a situation where we are going to be on a purchasing drive. Now, about 1,000 aircrafts are in order, are under order. Both in if we talk about the commercial market and the military systems. More than about 500, 600 engines are on order. If I take only Tejas at this point in time, and when we talk about AMCA, then we have to add up the number of engines that are going to come up there. And already we are having a sort of a distributed structure over there. Because just remember one thing, that when a designer goes into designing a platform, for example, when Arjun went into design, one of the first things that was fixed was the engine. Bodybuilding can take place at any time. Bodybuilding is, people on the roadside will do bodybuilding for you. But what is sort of important here is the engine, and therefore they fixed the engine. And what engine did they fix? We all know that. It's the MTU engine. And when we talked about the Tejas, we fixed the G404. We have gone to the G414. And when we are talking about AMCA, we are talking about the Safran engines or the Kaveri upgraded engine by Safran. And a lot of discussions are taking place at different levels. Rolls-Royce came and gave us and offered us some technologies around that. And I think ultimately we may land up with Safran for the AMCA, because that's going to talk about, I think, 110 kilonewtons or 120 kilonewtons engine, which will be the upgraded Kaveri engine. And while the Kaveri was also the dry engine of Kaveri has a lot of effort from Godrej, I think we are not capitalizing on the capabilities of the Indian industry. So, for example, if companies like Godrej, MTAR, Tribeni, and there are a number of these companies which are into these technologies. But coming to specifically to power, Godrej has done quite a lot of work in this space. So is there a way that we can fund them? Is there an innovative model? If it was a DPSU, we would have thrown money into it and said, okay, let's put more money into it, another 5,000 crores or 3,000 crores. But when it comes to Godrej, we said, no, let him do it by himself. After all, it's a national effort. We have to find out ways as to how we can help our private companies also through strategic funding. And this is something that we need to look more deeply into. And probably there we are talking about policy interventions in terms of the DAP and things like that. According to the United Nations Comtrade database, the power sectors, the increase in imports in the power sector is already reaching something like $69 billion, 69.68, close to $70 billion, and it's going to surge further. So the question is, where are we going to put the full stop, and where are we going to find futuristic developments and how do we prepare ourselves for the future? So I'll give you some statistics. Today, fixed wing engines, today we have got about 1338 fixed wing engine flying in the country. Rotary is about 962. 1,000 engines are coming in the next decade. And then we talked about, the emerging technologies in this. We talked about the fuel cells, the microgrids, supercapacitors, lithium-ion batteries, small modular reactors. In fact, amongst all this, I see a great potential in small modular reactors. and this is going to revolutionize the complete power, the concept of powering systems. And therefore, I think we are talking. In fact, this particular industry itself is close to about 20-30 billion dollars, and I'm talking about just India in the next about 10 to 20 years. And since it's an emerging field, this is something that we need to put our efforts on. We talked about the advancement in solar energy technology, intelligent power management systems, and then we talked about some of the characteristics of the military power systems. I am not going into it because that's been covered very well. But one important thing, why we are talking about this 5G, 6G, and power, and what is so critical about the whole thing, it's all about the cyber attacks. The cyber attacks that will come on the power infrastructure is going to be very, very serious. We have seen it happening in the past, and we have also seen it happening worldwide, and this is going to cripple the nation at any point in time. So I'm going to give you just 5 points now. Point number one on the TRL and MRL levels of various power systems. We just tried to map as to this is purely an EY research that our youngsters have done here. In terms of marine engine, we are talking about a TRL level of about 5 to 6, and the MRL around 6 to 7. Aero engines, again, we are talking about a TRL. We are about 4 to 5 in terms of aero engines. We have developed a number of systems, number of subsystems in this, and it's only a question of how we are going to take care of the extreme temperatures that the engine is going to handle at that point in time, and how the power is going to be transferred. We are talking about both transmission and generation. The battle tank engine, of course, we are at 7 to 8, and both MRL and TRL, we are at 7 to 8. Rocket engines, we are at 9. MRL also at 9. There are startups which have done extremely well in rocket engines. I think that's where they have also gone in for Series A, B. I think Series B funding also has taken place. So we are going to see an increased inflow of funds into the rocket engine segment. And when we talk about just the LEO and the MEO, we are talking in terms of about the worldwide, the statistics, the business opportunity is about $3 or $4 billion, and India itself is launching, is going to be a very major player in this, and we are there. We are competing with China. We talked about solar fabs. We are at TRL 7 and 8, and AIP for submarine, again, we are at a good TRL level today. Since Dr. Roy Chowdhury's name was mentioned, I think he's going to talk about it. We are already at 8. And I think with a little bit of help, I think if I'm not too wrong, there are some foreign companies which are also planning to partner with DRDO in this. And one of them could be Naval Group. And I think the best part about the French is that what they suggest, both in the engines for the AMCA and for the AIP, is we will develop your AIP for you, and we'll make sure that the P75I gets an Indian developed AIP, and I think that looks very good. For the male UAV engines, we are at TRL 6-7. Missile propulsion, we are at TRL 9, MRL 9. So missile propulsion, we are again doing good. I think that is one of the greatest success stories of DRDO. It was developed in a mission mode, and I think we are seeing the results today, and we are going to be placed amongst the most powerful companies. So who are the companies working here? This is the second point. Dry Kaveri, we have seen Godrej, GTRE, UAV engines, VRD, T7T, ABNL, armored vehicles, Ashok Leyland, Tata, Mahindra, BHEL. There are a number of these companies, and I also see companies like Multisphere, and I see Colonel Umesh, whom I know very well. And these are the things, why I'm talking about Multisphere and Umesh is, this is the type of a JV which is required where you get the fundamental technologies in and build up your TRL levels to a level that, you start exporting. And I think that's going to happen very soon. In air independent, we have seen L&T manufacturing 2 fuel cell-based AIP systems for the Kaveri, for the Kalvari submarine. And in batteries, we have seen FC Tech Energy, Colonel Ramandeep Singh, or I remember I visited FC Technology way back in 2010 or 11. A very inspiring company to see. We have seen number of them, and then The engine suppliers for light tanks, we talked about its Cummins. Um, are we still, why, where is a Kirloskar in all this? I always keep thinking as to, we have these companies and why are we not able to propel our own companies into these whole thing? Tejas G, of course, Vikrant AS is a Jirik G, marine engine, P-17 frigate G, ATAGS Cummins, and Rafael is, I think we are looking at Safran, and also for the AMCA. MQ-9 is Honeywell, Apaches. So what are we doing with these companies like Honeywell and Safran? So Honeywell has got a number of other technologies which we can leverage. And although our offset policy today is on the weaning side, but as a very strong proponent of offsets, and I've been the founder director of offsets in the MOD, and the first policy went out of my desk. So I am passionate about this. Can't we twist the arms? Can't we flex some muscles here and say, okay, if you are coming in for this and you're doing this for us, I want you to do the following things in India. So then the cumulative demand for energy is going at a very, we are talking about 220 gigawatts by 2030. And what is the government doing? There is a FAME-2 scheme. There is a PLI for advanced chemistry cells. And some of the recent developments have already been highlighted. So if I were to pick up just 2 points from the entire thing, I would pick up two fundamental. If you want to be Atmanirbhar, you have to be Atmanirbhar at the fundamental level. And the fundamental level is materials, chemistry, physics, mathematics. If you are able to, if this is the collaboration that we are expecting, DRDO today has got about 15 Center of Excellence established. And there are a number of our universities which are doing some excellent research jobs. But what is motivating them to do it? One is a scientist's own motivation. And I'll tell you a very small example here before I conclude. When we talk, I'm not related, of course, on 5G and telecom, IIT Madras had developed so many technologies, so many patents filed. At the end of the day, there was no buyer. So there was these Germans and other European nations which get a wind of this. They come, they pay some 5,000 euros and they buy off that technology and go away and build a 1 billion empire in Germany. This is a live example. And why we could not exploit it here? Because that IIT professor was there, he developed it, he says, when there are no buyers, then he says, okay, 5,000 euros, he says, it's okay. So I think we need to get a little more on that. So like General Verma also mentioned, materials and power and chemistry, I think these will be the 2 things that we need to do. And while I conclude, I want to conclude again with a quote from Bhagavad Gita, which Lord Krishna says, Vyavasayatmika buddhi eko hi kurunandana. Vyavasayatmika, resolute mind. Vyavasayatmika buddhi, a resolute mind. Eko hi kurunandana, there is only one way. You have to be resolute, you have to pursue that. And bahushaka anantascha buddhayo avyavasayinam. If you are not resolute in your mind, it will be bahushaka, many branches, anantascha, infinite number of branches, and therefore that will lead you nowhere. So therefore with the vyavasayatmika buddhi, I think we need to build up on the power systems. We need to ensure that our war fighters get the best power, the pure power. Therefore your equipments are safe. They don't need UPS. They should not need stabilizers. They should not need. So therefore that all comes from the purity of the power supply. Ladies and gentlemen, thank you. Jai Hind.